video, again, finds you happy and healthy. What we're going to do today is a short section on 6.3. It's another algebraic method to solving a system of equations. And remember we said a system of equations is when you have more than one, in this case, line. They don't always have to be lines, but we're dealing linear equations. And we're trying to figure out what x will give us the same y. And so on the last video we did the substitution method, and this is a nice method. It's called elimination, and it's nice because sometimes you'll get these systems where, you remember with substitution you wanted to find the variable that had the 1 in the front, and then it was really easy to solve for that. Well, if you notice all of these, well, that one does. This one down at the bottom, we could solve for y pretty easily there, but for none of these we could solve for y or x pretty easily. We're going to have fractions floating around. So this method's a nice method to use if it's not really easy to solve for one of the variables. So it's called elimination. I like to call it elimination addition because we're going to add to eliminate a variable. So the first two are set up nicely for us. So your goal is to get the same coefficient but of opposite sign in front of one of the variables. So this one's set up for us. You see we have a -5 and a +5 in front of the y. So we can eliminate the y right away if we add these equations together. So let's go ahead and do that. So I'm going to add the equations. So 4x plus 3x, that's going to give us 7x. -5 plus 5 gives us 0y. So I'm just going to cross those off because we don't need them anymore. It's a 0y. Why would we write 0 times y? It's just 0. And then that equals 3 plus 11. So that equals 14. And then we just solve for x. So to undo multiplication, we divide. So it looks like we're going to get x equals 2. Alright, so pick one of the equations and we'll substitute in here. I'm going to use the first equation. We're going to substitute in x is 2 to solve for the other variable, because remember they're ordered pairs. So 8 minus 5y equals 3. Let's subtract 8 from both sides. So -5y equals -5, and then we'll divide by -5. So y is going to equal 1. So there's my ordered pair, 2, 1. But let's check it. So let's check it into that equation we haven't used yet. So 3 times 2 plus y is 1, 5 times 1, does that equal 11? So we've got 6 plus 5 equals 11. Yep, so 11 equals 11. So you check it, so you use the one equation to solve for the other variable, and then you use the second equation to check it, just to make sure. I mean, if you want to pop it into both, you could. You could do 4 times 2 minus 5 times 1 equals 3. You could do it that way as well, but I always use one to solve it and then the other one to check it. Okay? So, I mean, if you want to pop them into both, you can. That's definitely can't hurt. Alright? So this one's set up really similar. So stare at it and just, see, do you have a variable with the same coefficient but of opposite sign in the front of it? This is where I would ask someone, I would say, Dakota, what do you think? And Dakota would go, oh, you've got a 3 and a -3 in front of the x. So we can get rid of that. So it's all set up nicely for us. So if we add 3 minus 3 gives us 0x. So we don't even need to write that variable down. We've got 2y plus 5y. That gives us 7y. And that is equal to 9 plus 12. Right? The equals comes down, and then we'll have 21. See how nice that is? So now we'll divide by 7 to get the y by itself. All right, so if we know y, then we can pop that in here to solve for x. So I'm going to use the first equation to solve for it, and the second equation to check. So we've got 3x plus 2 times 3 equals 9. So 3x plus 6 equals 9. So I'm going to subtract 6 from both sides. So 3x equals 3. And we're going to divide. So then it looks like x is going to equal 1. So my ordered pair, right? We need this as an ordered pair. So the ordered pair is 1, 3. That's what you would write on the solution line. So now let's check it. So I use the first one to solve, so I'm going to use the second one to check. So here, I'll write it out. Here's the equation. That's the second one. And so when x is equal to 1, y is equal to 3. So we'll have negative 3 plus 15 equals 12. There we go. So we did good. So 12 is equal to 12. We did great. All right. Now the other two are not necessarily set up for us. I mean, do you see you've got a 3 and a 4, and then a 2 and a negative 1, right? There's a 1 there, understood. So it's not set up beautifully, right, where we can just jump right in and add, and a variable will cancel. But what we can do is we can multiply one equation by a constant, right? And so then we can set it up. We can rig it so we'll have the same number but of opposite sign. So I'm looking at this. I'm looking at the y's. So in order to get the sign's already opposite. So if I just had a 2 here, I'd be good to go, right? I'd have a positive 2 and then a negative 2. All right. So let's work with that. So if I multiply this equation by 2, every piece by 2, left and right, it's going to be 2 times 4x, that's 8x. And then 2 times negative 1 is negative 2y. And then 2 times, everyone gets a 2 on both sides. And then, I just said it and I didn't do it, times 2 would be 22. Ah, now we've got an equation that has a negative 2. This has a positive 2. So now do you see we rigged it? So now if I add them together, it looks like I'll have 11x. These cancel, and that's going to equal 55. So when I divide by 11, looks like we're going to get x equals 5. So now I'm going to use the first equation to solve. 3 times 5 plus 2y equals 33. And then I'll use the second equation to check it. So 15 plus 2y equals 33. I'm going to subtract 15 from both sides. So 2y equals, looks like 18. So y is equal to 9. So there's my ordered pair, 5, 9. So I used this first one to solve, so now I got to use the second one to check, and I'm going to use the original. So this is the original equation. So now when x is 5 and y is 9, do I get 11? Yep. So we did good. We did great. All right, so what happens if you said, oh, you know what, Kathleen, I didn't want to eliminate the y's. I wanted to actually eliminate the x's over here, which you definitely can do. Let me just show you. I'm going to cover up what we did. And you don't need to write this down. I mean, you can, but I just wanted to show you something. Okay. You could technically eliminate the x's. So we could easily get a 12 in both of these problems by if I multiply this by 4 and maybe this by 3, that would give us both 12, but I want one positive, one negative. So let's say I'm going to multiply this guy by 4, and then I'll go ahead and multiply this guy, this equation, by negative 3. Do you see now I'll have a 12 on the top in front of x and a negative 12 on the bottom in front of that x? And then they'll be able to cancel. And it's a lot more work, but you could do it. So 12x plus 8y equals, oh geez, 33, yep, 33 times 4, 132. Okay, and then if I multiply this by negative 3, that would give us negative 12x. Negative 3 times negative y gives you positive 3y. And then negative 3 times 11 is negative 33. So if you add them, the x's will become 0. And then we'll have 11y equals, I need our calculator, I'm not doing any of this in my head, 132 minus 33 is 99. So then if we solve for y, we would divide by 11, and then there's your y equals 9, right? And then, which I think was what we got before, yep. But if I'm covering it up, then I would use the first one to solve for x, and then the second one would be my check, which is what we just did. So 3x plus 18 equals 33, right? And then we're going to go ahead and solve. I would subtract 18 from both sides. Equals 15. And then if I divide, do you see we get our x is 5? Oop, show it to you. Yep, so it's a little bit harder that way, not harder, just longer. I always try to find, if it's possible, the easy, like where I only have to multiply one equation by a number, and then it cancels. But you can always eliminate either variable. One might just require a little bit more steps. All right, I just thought I'd show that to you. So let's try the next problem. All right, so you could eliminate the x's, they're opposite sign, but it's going to be like a two-parter like we just did. Like you'd have to multiply this guy by 3 and that guy by 5, right, to get 15 in the front. So it requires a little bit of work, but you see it's easy to change the 3 into a 6. I just have to multiply it by 2. And if I want the signs to be opposite, then I just have to multiply this by negative 2. So that's it right there. So I'm going to multiply both sides of that equation by negative 2. So that will give me negative 2 times negative 5 is positive 10. Negative 2 times positive 3 is negative 6. And then negative 2 times 9. Don't forget, you got to multiply both sides. That's what people tend to forget. They forget to multiply it by the 9 as well. So that gives you negative 18. And then I didn't do anything with this guy. This guy stays the same because you see now we have a negative 6 and a positive 6. So when we add them together, that gives us 0. So we'll cancel those out. And then we'll have 13x equals negative 39. All right, so to solve for x, you would divide by 13. And it looks like x is going to equal negative 3. All right, that's in order to pair, so we need the y. So I'm going to use the first equation to solve. And then the second equation I'm going to check. So let's plug in -3 for x. Okay, so -5 times -3 is 15. I'm going to subtract 15. Okay, so we have 3y equals -6. And to divide to undo the multiplication, you'll get -2. So -3 comma -2 hopefully is the answer. So let's check it. So down here I'm going to do my check. So I'm going to use the second equation, this 3x plus 6y equals -21 to check it. So when x is -3, y is -2, so I'll have -9 plus -12. Does that equal -21? Yeah, it does. So we did good. We did great. All right, let's try one more, and then we'll do a little review, okay? So, the fractions. All right. If you don't want to deal with the fractions, honestly, you can just get rid of them, right? A lot of people don't like looking at the fractions, so let's just practice. You don't have to do this, but it is a nice little practice to get rid of them. So to get rid of the fractions, remember you want to find the least common multiple. So the least common multiple for 2 and 3 would be 6. The multiple they have in common is 6. So I'm going to multiply every piece by a 6. So you get a 6. I'm just going to put a 6 in front of everything. In front of every number. Oop, I just put a 3. Every number gets a 6. You get a 6. And you get a 6. So let's rewrite this out. I'm going to rewrite it out so it looks a little better then. Okay, so 6 times -1/2, if you pop that into your calculator, that should give you -3x. If you put -6 times 1/3 in your calculator, that'll give you -2y. And then -1 times 6 is just -6. That's much easier on the eyes, right? And then we'll do the same thing here. The common denominator would be 6. So I'm going to basically just put a 6 in the front of everything. You get a 6. The 2/3 gets a 6. And the -8 gets a 6. Everybody gets a 6. So I mean, if you don't see it, you can just do this on your calculator. I mean, you can use your calculator for everything. So, right, if you didn't see it right away, that would be -9x plus, let's see, we've got 6 times 2/3, right? So that'd be plus 4x equals, and then hopefully you guys, 6 times, or -8 times 6 is -48. I'm a little sleepy, so if I make a mistake, let me know. It's late at night. I'm doing these late at night, guys, in case you're wondering what time it is. It's like 11 o'clock at night right now. All right, but it all's quiet in my house, so this is a good time to make these. All right, so now this is our system right here. So it's pretty easy. If you want, you could, these are both negatives, so maybe you'd want to multiply this by -3 to get a +9. I'm liking this one because the signs are already opposite, so I just have to figure out how I can make that -2 a -4. So I'm just going to multiply everything by 2. I'm hoping that makes sense, right? If I want these numbers to be the same but of opposite sign, so since this is a 2, if I just multiply that by 2, then that would be a -4. But I can't just multiply that by 2. Everyone gets a 2. You get a 2, you get a 2, and you get a 2. So let's write my new system right here. So I'm going to have negative 6x minus 4y equals negative 12. 2 times negative 3 is negative 6. 2 times negative 2 is negative 4. And 2 times negative 6 is negative 12. And then nothing happens to him. We want him to be exactly the same, right? So now, when I add these guys, oh, that looks terribly like an x. That should be a y. Now, when I add, oh, well, no wonder it looks like an x. This looks like an x too. My handwriting's terrible. There we go. That should be a y. So these guys cancel. Nice. So now we've got negative 15x equals negative 60. All right. So let's divide to solve for x. So it looks like x is going to equal 4. Now I always go back to the original. That's just the way I was taught this. Always go back to the original to solve for the missing piece. You don't have to if you don't want to. But we've got our calculator, so we can easily pop in a 4 in there. Alright, so that'll be negative 2 minus 1/3 y equals negative 1. So I'm going to add 2 to both sides. So negative 1/3 y equals, it's like just 1. And then I'm going to multiply both sides by negative 3. The reciprocal of that, right? Or if you want to divide by negative 1/3 both sides, you'll get the exact same answer. However you want to think about it. But hopefully you got y equals negative 3. So there's my ordered pair. 4, negative 3. So I used the first one to solve for the unknown. So I'm going to use the second one to check. So let me write my check right here. Okay. So I'm going to use this equation. Okay. And so now let's pop in the x and the y. So when x is 4, y is negative 3. Looks like calculator work. Okay, so let's just pop it in our calculator. So negative 3 halves times 4 plus 2/3 times negative 3. Nope, it equals negative 8. We did awesome. We did awesome. All right, so there's your check. And so now I would pause the video, give it a pause, and then do both methods. Like, let's review both methods for this. Okay, you ready? So give it a pause, and then turn it back on, and we're going to do substitution and elimination. All right, here we go. So I'm going to do substitution first. And then I'm going to do elimination over here. Okay. So substitution, remember, I always say, like, search for the one that has the 1 in the front, because that's the easiest to solve for. Otherwise, you're going to have fractions in the problem, and we don't want that. So it's just easier, I think. It's easier on the eyes to go ahead and, do you see that the y is what we're going to solve for? Right? It's easy to get y by itself. So I'm going to rewrite this. I'm going to subtract 4x from both sides. And then to get y by itself, you guys okay dividing by negative 1? And you want to divide each piece by that negative. So we'll get y equals negative 11 plus, negative divided by negative is a positive, plus 4x. All right, and then we're going to use this equation to substitute into the one we haven't used yet. So we're going to put that y in for the other equation. Okay? All right, so I'm going to write it right here. So we've got 3x minus 4. Instead of the y, I'm going to write negative 11 plus 4x. And so this way we have one equation, one unknown, and we just have to solve it. We know how to solve these. So let's get rid of the parentheses. So I'm going to distribute through the negative 4. Remember, you can't separate the number and the sign. So negative 4 times negative 11 is positive 44. And then negative 4 times positive 4 x. So let's combine like terms. Okay, let's subtract 44 from both sides. Okay, so we had 18 minus 44. Do you guys get negative 26? Okay, and then the last step to get the x by itself is to divide. So did you guys get x is equal to 2? All right. So I'll use this equation, this one right here, to solve for y, because it's pretty easy, and then we'll use the other one to check it. So if we use this one right here, y equals negative 11 plus 4 times x, but x is 2. We just solved for it. So y equals negative 11 plus 8. So it looks like y equals negative 3. So there's my ordered pair. There's my solution. That's the x that's going to give us the same y upstairs. So let's check it. Because you know I like my check. Because I remember last time I made a mistake and it was because of the check told it to me. So we use this equation to solve. I'm going to point to it. We use that equation to solve for the y. So let's use this equation to check it. So I'm going to write it down here. You ready? So 3x minus 4y equals 18. Let's just make sure it works. So when I pop 2 in for x and negative 3 in for y, give you a chance to write that down, and then calculate it. Does it come out? Does it check? So 6, negative times negative is a positive, plus 12 equals 18. Aha! So we did awesome. We rock. All right. So that's substitution. Now we're going to rewrite it, and we're going to do it with elimination. We're going to get the same answer. Okay. So take your time and rewrite the problem. Okay? Take your time and rewrite. So I'm hoping you're seeing that the y's is where it's at, right? Like it'll be easy to eliminate the y. I have a negative 4 here. If this were only a positive 4, then we would be golden. So I don't want to just multiply everything by 4 because that's going to give me still a negative 4 and we want it to be positive. So does it make sense if I multiply everything by negative 4 for that equation? So that's going to give me negative 16x. Negative times a negative will be positive 4, and then that'll equal negative 44. So let me rewrite it because it looks a little scrunched. You ready? So the first equation doesn't change, and the second equation will be negative 16x plus 4y equals negative 44. All right. So now, if we add, and bring the equals down, we'll have 3 plus negative 16, so that's negative 13x. Negative 4 plus 4 is 0, so those just become 0. I'm just going to cross them off. And then we have 18 plus negative 44, which we already did before. That'd be negative 26. So do you see you're going to get the exact same thing? There's where our x is equal to 2. And then you could go through the process. Here, I'll just finish it. We've got 4 times 2 minus y equals 11. I just picked this bottom one to solve for x. You could have done it with the top one too. It didn't matter. 8 minus y equals 11. We'll subtract 8 from both sides. So negative y equals 3. And then divide by negative 1. So you see we're going to get the same thing, right? We'll get y equals negative 3, and then we already did the check down here. All right, so the My Math Lab is up and running. Let me know if you have questions. Zoom roomy, just send me a remind. Say, Kathleen, can we do a Zoom room? And honest to goodness, within a minute, you guys will be seeing each other face to face. So please consider that as an option if you need some help, okay? And next video will be up and running. Talk to you soon. Take care.